Hi, this is Mark Payne. Welcome back. What I'm hoping you'll have done is had a look at a previous video that I did looking at multi-rack native and latency when it was hooked up to a Midas M32 console. If you've not seen that video, a lot of what I went through there is prerequisite, and some of the stuff I'm going to go through is going to be pretty quick, covering stuff I went back. So I'll put a little link up on the screen now, so click on that, go back, maybe have a look at that, and then we'll tell you a little bit more about what we're doing here now. So I've changed the consoles. I'm now using a Midas Pro 1 and also a Yamaha QL1 as the hosts for this demonstration, and this is still about looking at waves using multi-rack, but I'm going to compare the latency and the performance of multi-rack native to multi-rack sound grid. So let's have a look again at the board as we did before, and I'll just go through a couple of these things that's going on. Sorry, I can't remember if I've introduced myself. I'm Mark Payne from SFL Group. I'm the technical director here, and we're a live sound company and audio-visual company, and we do hire and sales, and we're Waves Live dealers, as we are Midas dealers and Yamaha dealers and all these sort of things, but all this equipment is here for hire, and I want to take you through some of the capabilities of this stuff. So in the setup, we've got a measurement system which measures latency. Again, I covered it more fully, but basically I send some sound out, I go through a mixing console, we run some plugins, some Waves plugins on both of the consoles. That introduces some latency. Unfortunately, this DSP has some delay, and so we take the output of the desk back into the measurement system, and I can measure the latency using tuning capture. Again, look back at the previous video. Now, we've changed the scenario here. In the last video, I was only looking at using multi-rack native. In multi-rack native, that's where the user interface and also the DSP for the plugins run on a computer, and the computer we prefer to use for this is a Mac, and I'm actually using for this, as you know, quite an old Mac Mini, which isn't of any particular great performance, and it works fine, and we're really happy with running plugins here. But also I want to show you using that in a different scenario where we use a Waves server, a Waves DigiGrid server, and this is the smallest one they do, which is the Waves Impact server. And actually, that might not be true. I think there's even a smaller one than this, but it's a kind of entry-level Waves Impact server. And when we run multi-rack in SoundGrid mode, what happens is the DSP CPU overhead goes to the Waves Impact server. It's not run on the Mac computer or the PC that's running the user interface. Only the user interface works there. So the latency and the performance of this system, the Waves Multi-Rack SoundGrid and the Waves Multi-Rack Native, well, they look identical actually. The user interface is identical, but the performance of SoundGrid, the SoundGrid system is way, way higher. So how am I going to get these two desks, the Midas Pro 1 and the Yamaha, to talk to this SoundGrid environment? Well, we're going to do it over MADI. And with the Yamaha console, we put a MADI card in the back of the console, and each MADI card that we put in, if you like, allows us to really do 16 channels. The MADI stream is 64 channel capable, but the limitation of a Yamaha slot is only 16 channels. So if you want to get more than 16 channels, you have to put a MADI master card in, and then you could put some extender cards to go with it to increase your channel count. Now, on the Midas side, there's no such thing as a card that goes into the Midas side. So we come out of the Midas board on AES50, which is a 96K 24-channel bus, and we go into a DN9650 converter, which converts us from the world of AES50 to MADI. And then we're really in the same situation as the Yamaha board. And this DN9650 has to do a convert from 96K to 48K, because my MADI world is going to be running at 48K, and my AES50 world runs at 96K, because the Midas board runs at 96 kilohertz. It's a very fast board, whereas the Yamaha board in this case runs at 48K, which is half of the sample rate. I've realised I've taken on a lot here to explain to you, but I'm also going to show you the difference in performance of using something like the fantastic RME MADIface USB for converting and getting our MADI stream into the computer. And then I'm going to show you the even better Waves DigiGrid MGB. Both of these interfaces are superb, and they offer slightly enhanced and better facilities. The Waves DigiGrid guy is the guy that you want to be using to get you into the DigiGrid environment. So that's a lot of stuff, that's what we're doing. So you've seen the consoles, Midas Pro 1, you've seen the Yamaha QL1. We've got our old friend, the old Mac Mini from last time, running Waves multi-rack. We've got my measurement PC measuring latency. So then let's go through some of the items that we've got here. This is the RME MADIface, and it's taking a MADI input. At the moment it's plugged into the Yamaha board actually, and it allows me to have 64 channels of incoming MADI and 64 channels of outgoing MADI. So when we start using this for effects, this is really our 64 channel effects loop, if you like. And over here we've got the alternative way of doing this using the DigiGrid MGB. And this also is a MADI interface, but now it's turning MADI into a DigiGrid, which is a Cat5 based proprietary network belonging to Waves. And the advantage of this over that, if you like, is this has got two independent MADI streams. So what we can bring into this device is a 128 channels of MADI on two independent MADI streams. So it's like twice that, if you like. But more than this, it also gets us into the DigiGrid network, which will allow us later on in this kind of tutorial madness lab session to show you that I can use the Waves DigiGrid Impact Server to do our plug-in processing, to take the load of that off of the multi-rack environment. And that is effectively that decision of making the processing for the DSP, whether it's on the computer, that will be multi-rack native, but with multi-rack SoundGrid, it's going to be running on the server. That's the basic setup of where we're at. Okay, so let's get to it. At the moment, I'm going to show you the beginning of this using my measurement microphone. My measurement microphone. There are no microphones here, okay? My loop back for the measurement system is directly into the desk and directly out again. So we're only measuring desk latency. We're not measuring any acoustical latency. So let's measure the default latency of this Yamaha console. And this is the Yamaha desk. We're not doing any MIDI. All that's happening at the moment is we're going straight into the desk on an analog and straight out of the desk and into the measurement systems. So let's measure it. You will hear the sweep tone. And in a minute, a few seconds of latency will pop up, and you can see down here that the latency that we've got is 2.5 seconds. Sorry, not 2.5 seconds. That would be disastrous. 2.5 milliseconds, 2.5 thousandth of a second, and that is as quick as a Yamaha QL1 goes. That's input to output. Now, it's interesting, if we do this with the Midas console, we can make a comparison. So what I'm going to do is basically unmute the channels into the Midas console, and I'm also going to make sure that I'm not listening to the measurement output of my QL1. So we're now over onto the Midas console. By the way, you'll hear the same thing all the while because I bust the output of this console into this console and then I record that. But the measurement path is on this console only. So now what I'm going to do is I'm going to do a similar test. And there you can see the inherent latency of the Midas Pro 1. Well, it's 8.5 milliseconds, and alarm bells should be ringing, because why is this console slower than that one? In fact, it's not. I mean, one of the things that Midas do, and I can show you here on the preferences, if I go to monitors and preferences, Midas are very clever with delay compensation. And what they give us is the ability to basically slow the desk down so that it's the worst case latency. So any internal effects that we insert within the desk are basically going to be latency compensated so that everything will arrive at all points of the desk. So this desk has been put into full front of house mode, where it does all that latency adjustment and basically slows a whole bunch of things down. If I put it into its fastest mode, i.e. monitor mix mode, low latency, it will turn all of that off. And now we're basically in the same kind of situation as the QL1 is. So let me show you the latency of the Midas board now. You can actually see now that the Midas console is running at around 1.5 milliseconds of latency, and it's more performant than the QL1, and part of the reason for that is it samples twice as quickly. So it's important. I'm going to leave the Midas board in this low latency configuration, because otherwise we're not going to be measuring plug-in latency. We're going to be messing around with looking at that kind of configuration idea for the console. So all good. That shows you the relative latencies of the two consoles, and they're nothing to worry about. They're highly performant. So I've just gone back over to the Yamaha board. Now the next thing I'm going to do is bring in the MADI loop into play. So effectively we're going to go out of the Yamaha board using the card, and we're going to go through here. Now I'm going to turn on an insert point, and what I want you to do and what I want you to imagine is I'm actually going to take the MADI away from the MADI interface, and I'm going to connect the MADI output to the MADI input. So that is my plugin. You know, it's not a very interesting plugin, but it's going to do nothing. And so all we're doing is we're measuring the effect of this kind of MADI loop. We'll just put that there. And what I'm going to do now is I'm going to take the measurement channel, and I'm going to turn on an insert point. And this insert point is going out of slot 1 and coming back in on slot 1, and that's how we're getting out through the MADI chain and back in again. So I'm going to turn that on. So my measurement microphone has now got a delay, and it's not a very interesting delay. All it is a delay that's going out a MADI cable and back in again. So you might be interested to see if that slows things down at all. Remember the red trace here was our Yamaha default latency, and I'm just going to get rid of this long trace on the Midas because it's not representative, but the red one is our standard Yamaha one. And let's run that again now that we've put this extra path in. Wait for that to come up. That didn't work. So why didn't that work? Well, I've been a bit naughty. I've not put the measurement path on. So the point of these kind of lab tests is to do them live and dangerous. I don't really like doing these kind of high performance, sting orientated stuff. I want to do it live with you so you can see it all warts and all. So let's go again. So hopefully we'll get some more latency, but hopefully not a lot more. In fact, you can see that really going out of this MADI path, which is very simplified at the moment, we're only going down the cable and back up the cable again, that's adding another 0.5 millisecond of latency. Not even that, in fact. So all good. Now what we're going to do now is we're actually going to do the proper thing, and we're going to take the MADI input and go into the RME MADI face, and we'll take the output. And this is a USB interface, so it takes our 64 channel 48k MADI stream and puts it into the Mac Mini. Sorry, I put my hand in front of that, didn't I? Puts it into the Mac Mini in USB. And we're really inserted now. This system is in line, and the measurement microphone is coming through this C6 compressor. Let's just show you that. You can see there a C6 compressor, so you should see that go active. If you have a look at my measurement mic, I've got the insert point turned on, so that's going out and back again through the C6. So keep your eye on the C6, and we'll just hit this sweep again. Here it comes. Now you can see here we've got a latency in the order of 11 milliseconds, and this should be no surprise because it's very similar to the latencies we were measuring with the Midas M32 console when we were doing it directly over the Midas M32's USB bus. So, and this is typical of the latencies we see using multi-rack native. So there's no big surprises here. I just wanted to get this as a benchmark for what's going on. Yeah, so far so good. Just to prove to you that this multi-rack really is inserted. If I need to hear what you hear again, so I'm now listening. I'm going to take my DPA microphone. I'm going to show you the first reverb unit, which is an IR Live reverb. I'm going to take this channel. I'm going to take the mix bus 1. I'm going to send some reverb, and you're not hearing reverb from the Yamaha. Look, you're listening to the reverb of the IR Live. We're fully using this multi-rack environment. That's one reverb. Here's another one, a longer one. That's the second reverb that I've got. Let's turn that down because otherwise it's very confusing. This is my second Lexicon emulated reverb. And then let me show you the doubler again, just to show you that all of this is inserted as it was before. I'm not sure what that was, but that's Matt. Say hi to Matt, who's got his phone doing things in his pocket. This is the doubler, so I can center that on this send here. So there's the doubler. You can hear that doubling up as I send it to the send. So that's all good. That's all inserted. Happy days. Right. Okay. So that's a demonstration of what's going on there. Now we can send this over to the Midas side. It's reasonably easy for me to do that. This is the Midas's MADI, except it's not. There's some work to do here. Look, this is a DN9650, and the job of the DN9650 is to take the AES50 streams. There's 24 channels here on Cat5. Let me unplug it so you can see it. AES50 is a Cat5 network orientated thing. It's 96K and it has 24 channels on this. 24 channels in and 24 channels out, and then there's another 24 in and out here. And the job of this box is to turn the incoming AES50 to a MADI stream. That's what it's doing. And it's also sample rate converting, because it's not only is it dealing with the conversion of the format, but it's also dealing with the conversion of the sample rates from 96K and down sampling to 48. So I'm going to throw the away the link from our Yamaha board and pop in the link from the just get this the right way around, the link from the Midas board. And then what I'm also going to do is I'm just going to make sure that when I go back to this, I've not got things inserted that I don't want. And I can turn off the measurement system here. I don't need that. Don't need the measurement output. We'll come over onto the Midas board and do the business that we need to do. So we've enabled the measurement system here. And we're now measuring Midas latency, but as yet I haven't turned the insert point on. So let's choose the measurement channel. Let's just go home and let's turn the insert point on, so we are inserting the C6 compressor. And even you can see that I've obviously got the C6 compressors inserted, otherwise you wouldn't see any activity here because we're now over on the Midas side. Let's bring up the C6 that's on the measurement channel, just so that when I do a measurement you'll hear it and see it. So here's the measurement now of this latency of the Midas board doing the same thing that the Yamaha board was doing. Now it's a little bit more. It's a little bit more by about 1.5 milliseconds. Why is it more? Because the Midas board goes quicker than the Yamaha board, and we already showed that the latency was actually slightly better, but now it's slightly worse. Now the reason it's worse is because this thing adds a little bit of latency. Converting from AES50 and into the MADI stream, takes about a millisecond, and it takes about a millisecond when we turn it back the other way and we go from MADI back in again. So I know I'm doing this quick, but I'm trying to show you the relative kind of benchmark performances of using multi-rack in this way. Okay, so I'm hoping that's reasonably straightforward, and we're seeing a single plug-in latency of around 11 to 13 milliseconds depending on what board we're using, and that's very similar to the performance we saw with the Minus M32. Okay, so now we've benchmarked that for you. I think we ought to move this forward, and we ought to look at using the larger, if you like, the MGB, which has got more channel capability, and compare and contrast that. So there's quite a lot of configuration to do this. So let's go back to the Yamaha situation to begin with. So what we're going to do is I'm going to turn all this off, and also turn the measurement system back on the Yamaha board. That's that bit done. Let's also take this away so this doesn't confuse us. And let's take the Yamaha board and plug the Yamaha board into the MGB. So this is MADI Stream 1, in and out. Now Matt, as I did that, if you look on the back you can see there's a little light that tells me I'm getting a MADI sync. Look, if I pull that out, I get nothing. So that's a MADI stream coming in, going back out again. The job of this device is to convert this MADI stream into Cat5 digigrid, and so that's all fine. Now there's something obviously wrong here, because this is flashing red, which means he hasn't got his firmware. He's not connected to a driver, and the reason he's not connected to a driver is because all I'm doing here is I'm using a simple network switch as part of my hub, and it's not going anywhere. Look, this is sitting in isolation. We need to connect it up to the well, we're going to connect it up to the Mac Mini. So let's take a network cable, which I've got here somewhere, this yellow guy. So I could connect this directly into the Mac Mini, but I'm using a switch because it enables me to add more things later. So that's gone there. This is just quite simply going into the network connection in the back of the Mac Mini, which is there. And you'll notice what's happened is that the light's gone blue, because this has been recognised and there's a driver connected to it now on the Mac Mini side. Okay, let's configure this so that we can use the MGB sound card driver. So we're going to go into WSG Studio. And when we go in here, we can see that we've got the driver software for the sound card ready to go, but we need to put it into use. We want to we have it, it's turned on, and it's being used by our software. You'll notice in the on the rack side, on the hardware side, we can't see the MGB, so that needs to be added. So we just click on the little drop down, add the MGB, and this gets loaded in. We connect to the SoundGrid network, which you can see here, and now we can see the MGB. If we click on the settings for the MGB, which is the little star down here, we should bring up the MGB's control panel. So that's loading now, and there we have the MGB's control panel, and we can hit the identify just to make sure we're talking to the device, and you can see the device is now going through its little song and dance routine on that LED, so we know that we're definitely talking to the device. Can you see the device is being clocked by MADI? It's running at 48k. We're turned on external word clock, which means it's going to use its MADI port, and it's using MADI port 1, which is the correct one to use, because MADI port 2 isn't connected. Okay, so that's all good. Okay, so the next thing we need to do is we need to make a patch connection effectively between the devices. If we just turn off here, can you see that we've got our MGB and we've got the software of the software driver. So what we need to do is patch from the MGB to the software driver. This is basically sending our 16 inputs, if you like, and you can see them selected there. I don't need any more than 16 because I'm only dealing with 16 inputs and outputs from the Yamaha device. And we also need to make sure that we've got it patched in the other direction. That means we need to patch the software driver back to the MGB. And you can see there we've got 16 return paths. So we've got we're going from the hardware to the software, 16 channels, and from the software to the hardware, that's 16 channels as well. And that's effectively our return loop. Now, knowing that we've patched it correctly, we can now go into our Waves Multi-Rack Native, and we need to go in and change the configuration of this on its preferences, because we no longer want to use the MADI face. We now want to use Wave Sound Grid as our sound card, effectively. So I'm going to change over there. And in fact, say OK to that. You can see that we've obviously come alive because we've now correctly patched our Multi-Rack Native into the MGB. So all that configuration has happened. And now we can get to the point where we can measure the latency. So let's make sure that we're turned on the measurement channel, and that we've turned the insert point on. So that's going on now. And if you like, even we could have a look at the measurement channels, C6. So let's bring that open, and let's send a measurement pulse through and have a look, see what we measure. Okay, so now you can see that we're running with an 8 millisecond latency for the Yamaha board going through an instance of the C6 compressor. And I just want to run that again just to make sure that the C6 compressor is correctly inserted. So otherwise it's not a fair latency test if I haven't done this correctly. What I've done is I've just pretty much muted the output. You can see here in this situation, I've got no signal to noise ratio. I've got a signal to noise ratio of only 4.7 dB. So that pass obviously didn't work. Let's send ourselves back up to 0 dB on the output. We'll delete the last trace. We'll delete the one before, which was my good measurement, and we'll do it again. And so, yeah, we got good signal to noise, 40 odd dB, and you can see that we've got an 8 millisecond latency. So I hope this shows you just how good the MGB is as a sound card. I mean, I'm a great respecter of the RME MADI face, but even using the MGB in native mode, because we're still not using the sound grid system here, I hope that you can see that we've driven the latency down from around 11 milliseconds down to 8 milliseconds. So it just shows you what an effective sound card this is. And remember that it is a 128 input capable sound card. Okay, so that's all running quite well. So the next part of the story is converting this over to a proper sound grid scenario and implementing on the board the Waves Impact Server, which is this device here, and making that part of the network. So we've got some things to prepare there in order for this to happen. First of all, we need to make the hardware work. So quite simply, let me just grab a little network connection. The Impact Server, which is this box here, is it's quite simply, it runs a small Unix operating system which has been a Linux operating system, which has been kind of designed by Waves to run the plugins. And so there's really nothing to do with it. You never connect a screen to it. You don't connect a keyboard to it. You just turn it on and you plug it in. And that's just joined as a network device onto the SoundGrid network. And now that that's happened, I'm going to close out and go back to my SoundGrid environment, And in fact, I'm going to close out Multi-Rack Native because we're no longer going to be using Multi-Rack Native to do this anymore. So that's goodbye to Multi-Rack Native. Also in the setup here, because the software driver isn't going to be responsible for doing the I/O anymore, I need to free up this device. I don't need to be holding the MGB against the software device. And also I need to free this up as well. So we don't want this SoundGrid Studio environment holding on to either the driver software or the device itself, because we're going to give this responsibility over to Multi-Rack SoundGrid. So let's get rid of this because we're finished there now. So we're going to now run Multi-Rack SoundGrid itself, which is a program that looks exactly like Multi-Rack Native, but it's the SoundGrid version of this program. And in fact, we can even load, and I'll do this now. We're going to load my previous session. This is the same session that we stored. This is saying the session can change changes that you've not made. Well, I don't care about those. So we're now loading up the rack, the same rack, but it's not going to work because we haven't made the correct I/O assignments yet. So it's saying, what do you want to do? I'll use the file settings. So this is going to be a bit broken because it's trying to use the old sound card. Okay, so we got the same rack, but can you see now we're red in the inputs and outputs, because we really now need to configure this SoundGrid environment. So the way we're going to do that is, first of all, we need to go into the audio department and look at the SoundGrid inventory. Now, in the SoundGrid inventory, you can see that we can see Multi-Rack SoundGrid. Obviously, we can see this. This is the software itself. But we haven't got an assignment number for the MGB, the actual MADI hardware. Neither do we have a software assignment number for the SoundGrid driver code and also the SG server. So quite simply, we give them an assignment number. Now, it can be quite confusing. You're thinking, well, these are instance number ones. Why have I chosen instance number one when we've already used number one up here? But remember, this assignment number, this instance number, is not an instance globally of these things. It's an instance of the particular device. Now, what I mean by that is we only have one MGB. So this is MGB number one. We only have one SG SoundGrid driver, so that's number one. We only have one instance of the Multi-Rack program, so that's number one. And we only have one SoundGrid server, the Impact server, so that's number one as well. Okay, so all of those are set to number one, which might be quite surprising. Here we've got a chance to set and manipulate the driver latency for the SoundGrid network. Let's leave that default at 240. Get rid of that. We're finished there. Now we need to make some connections, and that's done here. We've done the inventory. Next we go to SoundGrid connections, and we have to double click to add a connection, and this is basically a patch. And what we're going to do is we're going to patch the MGB to Multi-Rack, and because we're using a kind of a 16 channel I/O rack, we're going to go 16 channels. So we've patched 16 channels from the MGB into the Multi-Rack software, and to make this work as a return though, we also have to double click again and make the reverse connection, which is Multi-Rack, back to the MGB. Again, it's 16 channels. So this is our send and return path, and we must remember to turn these on. Okay, so we've got 16 channels coming from the hardware to Multi-Rack and 16 channels coming from Multi-Rack to the hardware, and that's effectively our effects loop. Now we can apply that, and you'll notice that what's happened in the background behind the screen is that the input and output identifiers have gone away from being red, and again you can see audio. and we're now using MGB in its SoundGrid format. Now it's going to be interesting to see the latency, and just to make sure, because as I go through it's easy for me to forget, we've still got the insert point on the measurement channel, so we're still going through the C6, this C6 for the measurement channel. I'll just bring it up so you can see it. Now the difference is now the DSP that is required to run that C6 is actually happening on here, and the I/O that's required is actually happening on the SoundGrid server as well. The computer has basically become a user interface. It's not involved in the audio path. Now it might be confusing. If you remember, when I was doing the patching, I was patching to multi-rack, and that makes you feel that the I/O path is going to the computer. It's not. The computer in the background is redirecting that to the Wave server. So let's see what happens now if we run a latency path and we do a test. Now we've driven the latency right down to 5 milliseconds, and that's incredibly low latency for the amount of DSP processing that we're doing. And I can actually further improve that, or not improve it, but demonstrate just how effective it is. In the last session, you'll remember that I also had this maximizer. I can show you it on the screen here. It's the last of my rack effects. This maximizer is running on the final output. And yesterday, when I was doing this session, actually it was last week, my apologies, I'd inserted this, and I'll do it here on the main output. So this is the insert point of the main output bus, and you are hearing it through. You are hearing this microphone through that output bus, and that's now going through the maximizer as well. And yesterday when we did this test, it pushed the latency out to around 23 milliseconds, because we had a 11 to 13 millisecond latency for the C6, and then we had to go through the plug-in for the main final output L3 maximizer, and that ended up at a 20 odd millisecond latency. So we can do that test again. This is getting pretty busy. And can you see now that we're in a scenario where we have only gone up to 8 milliseconds of total delay around this system, and that's highly performant. And although I've demonstrated that on the Yamaha QL1, it would be exactly the same story if I do the same tests on the Midas Pro 1 also, because the thing that I've made in common here is this MADI interface. So hopefully that gives you a good idea of why you would want to run multi-rack SoundGrid. It gives us the ability to offload all of the CPU pressure onto the SoundGrid server, so our computer just becomes a user interface. This ends up going in a rack with the rest of the audio kit, so it becomes incredibly reliable to do that, and we drive the latency right down into the kind of below 10 milliseconds. And remember, I was talking about the Hass effect, and once we get into the 20 milliseconds, we can start to detect discrete events. Below 10 milliseconds, we don't know that we've inserted anything into this audio chain. So that's highly effective. In the next session, I've got a third session to do. I'm going to also show you how brilliant the Waves MGB is for doing dual parallel main and standby recordings, which I would normally use Logic Pro X to achieve, but it's incredibly reliable for generating parallel records. So come back and have a look at that later. I've been Mark Payne. This is sflgroup.co.uk, and I look forward to speaking to you soon.